This video digs into the code that will be used in lessons 4 and 5. Although students will not engage with this code until lesson 5, it may be helpful for the teacher to see what is going on behind the scenes. This code may look kind of complicated, but that's in part because it's broken up in ways that will be helpful as students explore the code in lesson 5. This code also has some other helpful features, like a comment on each main block that you can view by clicking the little note in the top left of the block. Just like that. To close a comment, just click the arrow. So zooming back out, at the top, we see these groups of blocks that deal with typical instructions around when and how often to run pieces of code. When button A is pressed, when button B is pressed, or every 10 milliseconds, that is 100 times a second. In lesson 5, students will notice that the names on the blue blocks we frequently see here, these are called functions, actually correspond to the names of the blocks at the bottom. Essentially, what's going to happen in this code that's different than what students have seen before is that these blue functions call the blocks down here, and then it will run all the instructions in the function before returning to the next line of code up here. So button B is probably the easiest place to start. What's going to happen if you press button B is it will delete the log and then show an X on the LEDs just to indicate that this happened successfully. Button A is going to begin the countdown to data collection. As you can see, it clears anything on the screen and deletes the log. And then it's going to set the stop time to 10 by default. This is the amount of time in seconds that the program is actually going to run once data collection begins. 10 seconds was selected because it allows students to see a number of peaks, but does not take a particularly long time to collect data. And then you see we call two different functions, starting settings and countdown. If we go down here, we can actually see what happens in starting settings and countdown. Starting settings is fairly straightforward, and we won't spend a lot of time going through every detail. But what it does is it sets a bunch of variables to whatever number we want them to start with, typically 0, and also adjusts some other settings so that it's ready for the program. Countdown is a little bit more interesting and corresponds to what students will actually see. You might notice that one of the different starting settings we had up here involved the delay and the delay count. The delay is 3 seconds, and that is called the delay count then. And we actually have that delay count by default at 3. If you wanted a longer countdown, you could set it to 5 seconds or more. However, what's going to happen is it will automatically count down to 0. And then when we get to 0 is where it gets interesting. There's a check mark that shows on screen, and in the instructions it asks you or the students to release the stick. Now, that does not mean that data collection will start immediately. There's actually an extra half-second delay in there, 500 milliseconds. And the reason for that is that we want to actually make sure that the data does not start collecting immediately, because the hand on the stick is going to cause some interference and potentially cause messy data. So by putting in that half-second pause before data collection actually begins, it's going to allow the curve to smooth out nicely before students see any data. The final thing you see here that might require some additional explanation is the time. By default, Microbit uses this running time, which does not particularly correspond to any inputs that you give it. But that means that if we just use that time, our data collection will begin at some random time. Could be anywhere from 20 seconds, even more. And so we want to set it to 0. And so what this current time actually does is it creates a separate timer from this running time. And so it's going to give us a nice clean 0 as a starting point when we start collecting data. Let's scroll up. Those two functions were called. And then the last thing that happens when you push button A before data collection actually starts is it sets ready to yes. Ready has to be yes in order for data to be collected. You might have noticed previously under starting settings that it is set to no until the countdown is through. So once our countdown's through, we actually begin data collection. You'll notice if we go to every 10 milliseconds, all this data collection requires ready to be yes, and the current time to be less than the stop time. And so when we collect data, a few different things happen. First, the current angle is noted, and then we call three different functions: peak checker, make data table, and counters. We'll go through these down here in turn. The first is peak checker, which you notice has its own separate subfunction called peak count peak time. And peak checker looks really complicated, but all it's doing is it's comparing a couple different recent sets of angles that were measured. And the reason why we don't just compare the current angle to the last one to measure a peak is occasionally the data does get a little messy, and that could cause us to get a false positive for a peak. The peaks are important because in lesson 5, we use them to calculate frequency, or at least estimate frequency. And so we want to get them right. And so this is comparing different recent angles to figure out if there's a peak or not. If it is, it adjusts the peaks up 1, and we'll record the actual peak height of that last peak in terms of the angle that was measured. And then it will call this count peak time. The count peak time simply creates an array, or think like a table, of different times since the last peak, and keeps a running counter of that. Then there were two other functions up here every 10 milliseconds: make data table and call counters. Make data table is going to record the current angle each time, make a nice table of that, whether it's a peak or not. And so we see here, we have a time column and an angle column. That's actually the output students would get when they download the results. And then we call this counters function. All counters does is it adjusts all the different angle variables of those different recent angles, as well as this peak pause counter, which just gives us a little bit of wiggle room before more peaks can be counted, once again, to prevent noise. It readjusts all that stuff. And so that's not super important, but worth noting. And then you might notice we have an if statement here, we have an else if here. And so if ready is yes, but current time is greater than or equal to the stop time, so if we've reached that 10 seconds by default, we're going to call display frequency. What that means is we're not collecting data anymore. Instead, we go back over here, we actually estimate the frequency using the number of peaks. Now, technically, it's whole cycles that we want to count. That's a little bit trickier to do, so it just uses peaks to get relatively close. And when we look at large sets of data, we end up with a fairly good estimate. And then after calculating that frequency, it shows the frequency on screen on those LEDs.